Let's take a look at solving some exponential equations. Solve for x in the equation e to the x minus 7 equals 0. So when taking a look at this, what we need to do is try and isolate the x term on one side. So you begin with e to the x minus 7 equals 0. We want to move that 7 on over. So you get e to the x equals 7. And there's a couple ways to approach it here. You could take a natural log of both sides and understand that natural log and e are basically e raised to the exponent are inverses. Or you could just realize this is another way to write a logarithm. And the way to write it is a log base e, but a log base e is the natural log of 7. So you have x equals either log base e of 7 or a natural log of 7. And that's your final answer. So moving forward, let's take a look at our next problem. Let's solve the equation 2 to the x plus 9 equals 0. So if you take a look at this one, we can begin by trying to isolate the x on one side. So you get 2 to the x plus 9 equals 0, or 2 to the x equals negative 9 by subtracting 9 from both sides. Now, if we're wanting to solve this, you might think, okay, we take a log base 2 of both sides, or we just write it x equals log base 2 and negative 9. But you have to think real quick. If we take a look at this graph of f of x equals 2 to the x, we're basically looking, when does the y value equal negative 9? But if you notice, the range of this function is only from 0 to infinity. So that means there's actually no solution since the range is 0 to infinity. So when you have a 2 to the x equals any negative number, that would be a no solution, just as in this case. Okay. Problem 3. Let's take a look at solve for x in the equation when we have 5 to the x plus 4 equals 27. So this may seem kind of tricky, but it's the same as most of the other exponential equations, except we have a plus symbol here. So we have 5 to the x, we can subtract 4 from both sides to get 5 to the x equals 23. And now that we have 5 to the x equals 23, we can remember this is another format for just writing a log with a base 5. So x equals log base 5 of 23. Another way you could have done that, once again, is take log base 5 of both sides. So log base 5 of 5x is equal to x, and then you have log base 5 of 23. Now, going from there, if we wanted to find like an approximation of some sort or write it in a different base, we could use our change of base formula. And basically what that does is, if we just write log base 10, we could write x equals log of 23 divided by log of 5. And it didn't matter what base we have in there. You just put what's on the inside of the logarithm. That goes on top with the logarithm, the base you want to use. And then the base that you have for your logarithm, that should appear in the bottom with our new base. So we have that log of 5 appearing right there. So those two coincide. All right, let's take a look at our next problem here. Solve for x in the equation 3 to the 5x minus 7 equals 9 to the 3 minus 6x. Now, this may seem tricky at first, but notice 9 and 3 you could write having the same base, and that base would be 3. And so what we would find then is that when we write 9 as 3 to some power, that would be 3 squared. So you get 3 to the 5x minus 7 equals 3 squared, that quantity raised to the 3 minus 6x. And by exponential laws, we just multiply exponents. So now we have 3 to the 5x minus 7 equals 3 to the 2 times the quantity 3 minus 6x. So moving forward from here, what do we have? We basically can rule out those bases and just look at the exponents, because the exponents would have to be the same for these to be equal. So you get 5x minus 7 equals 2 times the quantity 3 minus 6x, which means when we distribute that right-hand side, we get 5x minus 7 equals 6 minus 12x. Now we have to get our x terms on one side, the constants on the other. So basically we'll get the x terms by adding the 12x to both sides. That makes it 17x minus 7 equals 6. Now add the 7 to both sides, and we'll get 17x equals 13. And we have our final answer equals x equals 13 over 17. Now you sometimes have to check the domain, make sure things are in the domain, but luckily the domain of exponential functions is from negative infinity to positive infinity. So we really don't have any problems with these going on here. So 13 over 17 is our final answer. Okay, last but certainly not least is problem 5. Solve for x in the equation 4 to the 9x minus 10 equals 1 over 8 to the 4x plus 16. This might seem kind of tricky, especially with a fraction, but notice our bases are 4 and 8. Now you can't raise 4 to some power and get 8 to some power, but when you start to think about it, both 4 and 8 are powers of 2, and that's what we'll try and play with here. So you have 4 to the 9x minus 10 equals 1 over 8 to the 4x plus 16, and so both of those we're going to try and get in terms of powers of 2. We could do the 4 right away, that's just 2 squared. The 8 to some power, writing it as 2 to some power, first we'll do a trick to get rid of that fraction. Since we have a 1 on top, you can write this as 8 to the negative 1, and then that whole quantity raised to the 4x plus 16. That's because we have that 1 on top. You could basically have factored out and raised that 4x plus 16 as an exponent to the whole quantity there. So that means, moving forward from here, we can write 8 to the negative 1 as 2 to the negative 3, and we're just expanding that exponent on the left-hand side. So you have 2 squared. It becomes 2 to the 2 times the quantity 9x minus 10 up in that exponent. And so now we'll just do the same thing on the right-hand side and kind of set our exponents equal. So you get 2 to the 18x minus 20, and then 2 to the negative 3 times the quantity 4x plus 16. Now just set the exponents equal. We get 18x minus 20 equals negative 3 times the quantity 4x plus 16. So distributing on the right-hand side, we get 18x minus 20 equals negative 12x minus 48. We can add 12x to both sides to get 30x minus 20 equals negative 48. And now you get, adding 20 to both sides, you get 30x equals negative 28. All we need to do here is just divide both sides by 30, and you get x equals negative 28 over 30, which is the same thing as negative 14 over 15, giving us our final answer that we were searching for.